Right, in this video, we're going to do volumes of pyramids and cones. So in the last video, you did volumes of prisms and cylinders. Remember the formula for those two was just capital B times H. And capital B was the area of the base. It's just on the cylinder, the base was always a circle. So that's why they put pi r squared H. The formula is going to be almost identical to that with one little extra part today when we're doing volumes of pyramids and cones. So let's go get the PowerPoint so we can get started. Okay, I think it's going to be super easy. Okay, so let's go up here for a second. Volumes of pyramids and cones. Let's start with a pyramid. All right, we're going to start with this pyramid. Now remember, how do you know when something's a pyramid? You know it's a pyramid when you have majority triangles. Okay, so we did this one last time with like a little T box. See, I've got 1, 2, 3, 4 triangles, and then this one is some kind of rectangle or square, which is very similar to the one you have on your screen. All right, so what I'm going to have to do is, if a majority of the sides are triangles, that's how I know it's a pyramid. So that's how I know it's a pyramid. All right, now if there's any shape other than, if there's any shape down here other than a triangle, then that's how I know that it's what the first word is. So look, there's a shape that's not a triangle. That's a rectangle. So that's how I knew that was a rectangular pyramid. Okay? So that capital B is the area of that base, just like it was when you were doing prisms. So that capital B is going to be the area of that rectangle. How do you find the area of a rectangle? Don't you do length times width? So length times width. So the area of that rectangle on the bottom is 80 square inches. So all I did, just like with prisms, I replaced that B with those 80 square inches. This H is the height of the whole pyramid. So look how tall that pyramid is. So we're talking about from that apex on the top down to the base, perpendicular to the base. And see, they have a right angle right here to remind you that it's got to be perpendicular. It's 6 inches from this highest point straight down to this base. So that's why 6 inches goes there. So I've got to say 1/3 times 80 times 6. Remember, single numbers go over 1, and then numerator times numerator times numerator, so I get 480. And then 3 times 1 is 3, and 180 divided by 3 is 160. Now, what property says 3 times 1 is 3? Do you remember? That's right, multiplicative identity. All right, so that's the one that identity property of multiplication says that 1 times any real number is that real number. And remember, when it's volume, it's always going to be cubic units. Okay, so let's go look at a different kind of pyramid rather than a rectangular pyramid. Now look at this one. On this one, I've got all triangles. So it's a pyramid because I've got mostly triangles, but if it's all triangles, it's going to be a triangular pyramid. Okay, so the base is a triangle, so my capital B is going to be the area of that base. So if I'm looking at this triangle down here as my base, then I've got to find the area of this triangle down here. Now, what's your formula for the area of a triangle? Okay, it's 1/2 base times height. Now, this is a little confusing, so you've got to be careful. The H in this formula is not going to be the same thing as the H in this formula. Now, this happened sometime when we were doing prisms as well. So make sure you realize, if I'm doing area of a triangle, that lowercase b is the base of the triangle, and that H is the height of that triangle. So if I look at this triangle down here, do you see I've got a right angle? Remember, B's and H's have to be perpendicular to each other. So the base is 3 and the height is 3. So that's where I got 3 times 3, 9. All right. And then both of those, remember, would be over 1s. And I would do numerators times numerator and denominator times denominator. So I get 9/2 or 4 5/10 square millimeters. I can leave it equals because 9 divided by 2 is exactly 4 5/10. So that 4 5/10 is my capital B. So I replace capital B with 4 5/10. Now, this height is the height of the triangle, but the H in this form, because I'm doing volume, it's got to be the height of the entire pyramid. So how tall is the whole pyramid? So how tall is it from the top down to the bottom perpendicular? Do you see that it's 4 tall? They tell you it's 4 millimeters. So when I substitute in, that's where I got the 18 cubic millimeters. And remember, volume's always going to be cubed. So let's clear these. So when I go to the next one, it won't bother you, okay? Now the next one's going to be a cone. Now I want you to think about something. This only had 3 sides, and the one in front of before had 4 sides. What if I had 8 sides, or 20 sides, or 100 sides? Do you see that that bottom will get more and more like looking like a circle? Okay, so that's why this is going to be the volume of your cone. It's still 1/3 BH. Just like the pyramid. It's just if you've got a cone like a sugar cone, do you see that that base is going to be a circle? So that capital B is going to be the area of a circle, which is pi r squared. So all they did was they took that B out and put pi r squared, the area formula for a circle, in place of it. So that's why that's the formula for the volume of a cone, 1/3 pi r squared h. So let's go work a couple. All right, look at this one. Here's my cone. All right, so there's my volume, 1/3 pi r squared h. Well, look at this radius. This radius is 7 meters. So my r is a 7, but I've got to square it. The height is the height of the whole cone, which is 9 meters. Remember, you're looking for those heights. You're looking for right angles. So 49 times 9. All right. And then when you divide that by 3, when you put these answers over 1 and go straight across the top and straight across the bottom, you get 147 pi cubic meters. Make sure volume's always cubic. Now, on a test, you can leave it like this. If you'd rather give me a decimal approximation, you can replace that pi with 3 decimal 14. But if you do, make sure you change that equal to approximately equal to. All right, so equals with an exact answer, approximately equal to those wavy lines with a decimal approximation. Now, let me go show you something. All right, sometimes you got to be careful about some things. All right, so let me kind of show you what I'm talking about. I went and grabbed this one out of a book, and I want to make sure that you would understand something. If this was the problem on a standardized test, it's telling me I have to use 3 1400ths for pi, so I don't have a choice. Okay, great. So I go look at this problem. I need my radius. Now that 20 is my diameter. That's all the way across. So the radius is going to be half of that. So do you see why I put the radius to be my 10 yards? But the formula says to square that. So when you square 10, you get 100. Now I need the height of the whole cone. So the height of that cone is 18 8/10 yards. And on a test, I'm going to draw that right angle just to make sure that you understand that's perpendicular. And I multiply it. Now, on a test, if I just said find the volume of a cone, that would be a perfectly great answer. But see, that's not following the directions on this standardized test problem that I found, okay? So this standardized test problem wants you to replace that pi with 3 1400ths. So you do, and you get this answer. But if you type this answer in there, it may give you an error message, and here's why. This one said round your answer to the nearest 100th. Now, this is exactly what I got. I only got a tenth. I didn't get any hundredths. I don't need to round it. But they're probably expecting me to have a number in the hundredths column. So do you see that I don't have any hundredths? But if I put a 0 there, I still don't have any hundredths. So they might be expecting me to type this answer in there rather than 5,903 2/10. So just kind of warn your students sometimes that they may have to look for an answer that's equal to theirs, but might look a little differently than theirs looks, okay? And remember, part of my job is to teach you how to be a teacher. So just kind of warn. For me on a test, I wouldn't care if you left it like that or you had it the original way. I'd be satisfied either way. Just make sure though, if you change from equals to a decimal approximation, do make sure that you do change to that approximately equal to the way that they have. Okay? Now, let me show you something else. All right, here's a problem that I found on the internet. And it looks like a really good problem, okay? But it's got some issues. Now, part of my job is to teach you how to be a teacher. And I want to reiterate, just because you find something in a book or on the internet doesn't mean it's good. It may look good, but it may not be good. See, I've got some issues with this problem, okay? I don't think it's that great, all right? Now, it serves a good purpose. You're comparing a cone. You're basically getting them to do two different, it says which has the greatest volume. So they want you to do the volume of this one and the volume of this one and tell you which one's larger. Okay. Do you see this is a square pyramid? So my formula is capital B times H, all right, with that 1/3 in the front of it, okay? So I've got to find the area of that base. Well, it's a square, so the base area is 3 2/10 times 3 2/10, and that is, now, if you take your calculator and you say 3 2/10 times 3 2/10, you do get 10 2400, so I'm okay right now. Then they put 10 2400s in for capital B. So that's their 1/3 capital B times H. H, the height of the whole pyramid. But what I want you to do right now is to get your calculator out. Kind of stop the video, get your calculator, then come back and unfreeze it. Okay, now that you're back, look at what you would do. All right, so single numbers go over 1. So when you do 1 times 10 2400 times 7, if you do 10 2400 on your calculator times 7, you're going to get 71.68. Now you got to divide that by 3. When you divide that by 3, you do not get their answer. You get 23.89 with a whole bunch of 3s. So where did they get that answer? Do you see that they rounded it? And if you round, you don't need to put equals anymore because it's not right. That's not exactly right. There should be an approximately equal to there. So that's what I've got a problem about the math. The math error to me is that. Are the volumes exactly correct? No. They're approximately correct, so you got to warn somebody. And they do the same thing over here, okay? Now, matter of fact, over here, they do it twice. Do you see that your bottom is a circle? So your base is a circle. So you've got pi r squared. But if you say 3 2/10 times 3 2/10, all right, we already did that, remember? And we got 10.24. Well, 10.24 times 3 1400ths. All right. You brought that on do my calculator. All right. I don't get this answer. So what did they do? Well, I don't know if they used a better approximation of pi, but they certainly rounded it. So already they would need to warn somebody that they rounded. And see, I don't know what they used for pi. Did they use 3.14, 3.14159? I don't know what they used. But if they round, anytime you round for me, you need to change that to approximately equal to. And that's going to be the problem here. I need to change to approximately equal to. So the math error in this is if you round something, you've got to change from equals to approximately equal to. Now, here's to me a grammatical error, and you're going to be teaching reading and writing. When you're comparing two things, they should ask you which one's greater, not greatest. Greater is when you're comparing two things. Greatest is when you're comparing more than two things. Okay? So it's an okay problem, but it's not good for you to give an elementary student. So what I would do if it were me, I would probably have clipped the pictures and used the pictures, and then I would have typed out my own work, okay? Because I can kind of fix some stuff for you because you're 20 years old, all right? It's harder to fix something for somebody who's 10. So you need to give them things that are exactly correct. So just because you find something on the internet or just because you find something in a book, you have to what we call vet it. You've got to make sure it's exactly right before you hand it off to your kids, okay? So end of mini sermon, okay? Now, as far as what you're doing for me, you're doing those volumes of pyramids, 1/3 capital B times H. Capital B is the area of that base, all right? And then cones is still 1/3 capital B times H, but since your base is a circle, they'll put 1/3 pi r squared H. And remember, anytime it's volume, it's cubic units. Anytime you use pi as 3 1400ths, or anytime that you round something off, you change those straight line equals to approximately equal to, and I'll be a happy camper. Okay, so that finishes up your volume formulas. So you should be able to find the volume of something. Try that homework. If you have any trouble, email me and let me know.